So just, and again, an overview of our department. We're a 2-linac department, both Versa HD linear accelerators with XEOE, cone beam CT, and hexapod treatment couch that gives us 6 degrees of freedom. We currently use Monaco treatment planning system and Mosaic record and verify, and we're a fully paperless department. In terms of what Vision RT systems we have installed, each Linac bunker has the Align RT system, and most recently we've just got Gate CT. So in terms of both systems, we only have 3 months experience so far. So we are tattooless. We went tattooless straight away for all breast sites, and including DIVH. And for a high percentage of our thorax patients, we are now currently tattooless. We also use Align RT for monitoring of all patients. So just to give you an overview of the installation process, it was a really quick turnaround. Day 1 of phase 1 training to going live was 10 days. Going live was made very easily with having a dedicated app specialist on site for the whole week, which really helped out the process and just to streamline it, make sure everything went as smooth as possible. In terms of acceptance testing, again, it's really, really quite basic. When the system is installed and the engineers leave, everything works as it should. It's aligned to the ISO center. But as a physicist, that's not always good enough for us, so we want to do some extra testing. In terms of commissioning work, we wanted to make sure that Align RT was correlated and in good agreement with XEOE. So we used the MV cube that Vision RT provided us, sorry, and we looked at the correlation for a number of different ISO centers to make sure Align RT would calculate and match what our gold standard, which is our cone beam CT, is. We also looked at the coincidence of ISO centers, and that included the Linac, cone beam CT, our hexapod couch, and Align RT. We looked at some basic static localization tests, but for me the most important one is the end-to-end, the one that goes from CT the whole way through the treatment plan and workflow, all the way to delivery. And you can see from the slides, we were within 1 millimeter of positioning, a half a degree, and the expected dose that we delivered was less than 2%. So to move on, we all know, or I think we can all appreciate the benefits of Sgrt. No additional radiation dose. We can monitor the patient during beam delivery. But I think the main benefit for us was we wanted to eliminate tattoos from our center. We had 2 big questions that we wanted to ask ourselves before we implemented Align RT. Is Sgrt comparable to what we currently did, which was use tattoos and lasers, and also kind of reproduce on a daily basis patient setup? The first step we did, and we did this quite quickly, was to get the overall correlation between Align RT and cone beam CT in a clinical setting. So this group of patients included breast, thorax, and pelvis patients. We set up with our then current protocol using tattoos and lasers, cone beam CT'd, and looked at the match and the moves CBCT gave, and also the match that Align RT, the deltas gave. They were in really good agreement. Just to give you an idea of our standard setup workflow, we will position the patient now with Align RT. We will match their live image with an external reference contour that comes down from the treatment planning system, and we will minimize translations and rotations. We will then go outside the room and we will perform a cone beam CT. We will verify that the patient is within tolerance. If a move is needed, we will make that shift, and then we will continue on and we will deliver the treatment. The first audit that we did was using Align RT. We wanted to compare this to cone beam CT. So for all of these patients were tattooless. We aligned with Align RT, and we then performed a cone beam CT. We compared the both results, and as you can see from these bland outline plots showing the data, 95% of all data points fell within these limits of agreement. The bold central line was the mean of all set of error. This is an important one, and this is the main reason for my talk. The comparison between tattoos and Sgrt. In this, we had 31 patients with 226 image fractions on the Align RT side, and in the tattoo arm, we had 20 patients, 263 image fractions. The table there demonstrates the mean setup error, and in all cases, the Align RT setup error or mean setup error was less than that of tattoos. As our current imaging protocol in our department is to image on days 1, 2, and 3, and then to weekly, it was important for us that we could trust that we did not need to implement daily imaging. So it was reassuring to see that on only 15% of all of these imaged treatment fractions, only 15% was out of tolerance and actually required a move, compared to 30% with tattoos and lasers. In terms of the overall range of moves observed, in all directions using Align RT, the range of moves is less than that of tattoos. And again, this should, or at least give you a good feel that Align RT can accurately and reproducibly set up a patient on a daily basis. The reduction in range of moves you can see on the slide, it's 0.8 centimeters in the lateral direction, 0.9 in the longitudinal, and 1 centimeter in the vertical. We then, after that quick audit, we then moved on to see what other sites. And I think it's only a natural progression that we moved on to thorax. As I said, we're not fully tattooless for thorax, but a high percentage of our patients are. We did the same process. Initially, we still set up with tattoos and lasers. We would cone beam CT the patient. We would then look at what moves we needed to implement and compare that to what Align RT said at that time. Again, greater than 95% of all data points we used were within the 95% limits of agreement. We then again wanted to compare this to what our current or then current protocol was of setting up patients with tattoos and lasers. I can appreciate that the difference in number of fractions here is quite big, which could have some impact, but the results and the trend followed what we did see in the breast group. Again, the number of image or the number of fractions that actually required a move was more than we did see in the breast setup group, but it's still less than what we did see in the tattoo group, which again, for me, fully kind of cemented that we could use Align RT on a daily basis. You can see from the table there that in all but one direction, the mean setup error was less for Align RT. In the longitudinal, in the lateral direction, currently we're looking into why the results might have shown that. Could be down to, again, as we have only got the system 3 months, could be down to the ROI, could be down to just lack of experience at the minute, but we're hoping to get more numbers up so we can further look into that study. The box and whisker plots again show you that in all translational directions, the range over which the mean setup error was less, and it actually decreased by more than what it did in the breast group. So in the longitudinal, the greatest decrease was over 1.5 centimeters. Now, another main reason why we wanted to introduce Sgrt was so we could provide deep inspiration breath hold to our patients. To give you a quick overview of our workflow again, we initially set up with a free breathing DICOM that comes directly from our planning system. We will then ask the patient to breathe in, and we will set up using their breath hold DICOM, again, that comes from the planning system. We will make any longitudinal or lateral differences that we require. We will leave the room. We will ask the patient to, again, inhale and hold their breath, cone beam CT, and verify the patient's position. We can then deliver the treatment. The good thing about the system is that it will monitor the patient continuously, and if the patient does leave breath hold, the beam will terminate. So these are, so far, the results that we have with using Align RT for deep inspiration breath hold. You can see that the mean setup error in breath hold is very, very small. Out of the 59 fractions that are included in this, the percentage that actually required a move was really, really low. 86% in the lateral direction did not require a move, and that rose up to 95% in the vertical direction, which is what we would expect. It is worth knowing that three of the patients that were used in this required a rescan of their planning CT. They were very early on after we had it installed. We think this is down to coaching at CT. Maybe the patient relaxed into the treatment, but since then we now bring the patient in, let them familiarise themselves with their surroundings, and they seem to be a lot more comfortable when they do come in for their planning CT. This is just to show you some of the data that we looked at, that we recorded during beam on. And the average deviation during breath hold is really, really small, and it gives you a sense of the stability and how the system can and accurately track the patient's external contour during breath hold. We also wanted to look and see if the system could reproducibly set up the patient in breath hold on a day-to-day basis. And you can see from the figures there that from their external contour to breath hold 1, 2, 3, so on and so forth, the maximum deviation was 2.1 millimeters in the longitudinal direction. So, as a relatively new user, these are just some factors that we have learned from our experience that we think can affect the system. They're both user dependent and inherent system limitations. First category would be CT immobilization and setup, as I mentioned. 3 patients that we did have needed to be rescanned, replanned, and brought through the process again. One big thing with the system and with deep inspiration breath hold in general is patient compliance, ensuring that the patient isn't arching their back, they're relaxed, and they feel relatively comfortable for what they are going through. The correct immobilization, what I mean by this is, for example, if a patient is in a vac bag, the vac bag has to remain relatively low on the lateral sides so the ROI can be delineated correctly. In terms of the ROI, correct delineation is also important. For example, on the breast, coming across medially enough and down laterally enough to allow the system to actually check rotations. Also, the region of interest, the size of that, it is a trade-off between accuracy and frame rate. A larger ROI will have a lower frame rate, but potentially be more accurate. Also, during gantry rotation, some of the lateral cameras are blocked. This will not terminate the CBCT. So what we do is, to get around this, we will note the deltas before cone beam and after, and just ensure that the patient hasn't moved. During all of our VMAT treatments and all of our Sgrt treatments, we had to look into increasing our thresholds depending on what thresholds we had, as when the gantry rotates, it can potentially cause a little bit of signal distortion from Align RT, which can cause the beam to falsely terminate. So, quick conclusion, is Sgrt a reproducible option, and can we eliminate tattoos? I personally feel we can. It is accurate, it is reliable, it does not deliver any extra dose to the patient, it allows for real-time monitoring. CBCT will remain our gold standard, but on non-imaging days, Align RT is a good tool to accurately position your patient. No additional fixation is required for the patient to what already would be required. What next for our department? Well, we will push on to more sites to eliminate tattoos. We will be implementing 4D CT using gate CT and breath hold for SBRT treatments. We are in the process of starting up our SRS program using open face masks, and we will review all of our current tolerances for each site to see if we need to increase and decrease them to improve the use and optimize the use of our the system for us. Thank you.
Thank you very much for your very interesting talk, Carl. It's really impressive how great your results are in such a short amount of time. That's really brilliant. Are there some questions from you guys? Yes, please. Okay. Do we have microphones? Yes.
Hi, thank you for a really good talk. I do apologise if I missed this. Just regarding your DIBH patients for breast treatments, with planning CT, do you have a free breathing CT and a breath hold CT in order to do the matching?
Yes, we do. So you set the patient up again using the free breathing CT and the breath hold. We don't think it's a problem also taking 2 scans because the free breathing scan is a fallback option.
Okay, thank you.
Hi, Carol. We've just started using the line in Doha, and I was just wondering, have you tried it on any other sites yet, or are you just still doing the breast?
Just breast and thorax at the minute. As I said, we do use it for every patient for monitoring. This tends to give us a good feel of how it is going to affect other sites, but we will be moving to pelvis over the next month or 2.
So you monitor every patient with it?
Yeah, we currently use it for every patient, so we currently import the planning CT as the reference, but we won't use it. Sorry?
Do you find any benefit to monitoring other sites?
Yes, I think using a line RT to monitor the patient to an accuracy of, say, for example, 3 mils in translations is a lot better than what our current practice was of using CCTV to monitor the patient. So the beam will terminate if they move, if they arch their back, for example, on free breathing breast. So yeah, I think it's definitely a benefit.
Okay, thanks.